Have you ever looked at one of these incredibly powerful AI models and just thought, how? How do you even build something like that? Well, today, we're going to pull back the curtain on a single, really brilliant Python script. It shows us how modern AI is trained from the ground up, not with a blank check, but with some serious smarts and efficiency. Let's dive in and see what makes it tick. So here's the game plan. First, we'll unpack the toolkit that comes built into this script. Then, we'll get into the real secret sauce, its low-rank architecture. After that, we'll see how it trains smarter, not harder. Then comes the fun part, the art of generation. And finally, we'll zoom out and talk about why all this efficient AI stuff is so important. All right, let's open up the toolbox. You know, this script isn't just a file with some code in it. It's more like a collection of ready-made solutions for some of the biggest, most annoying problems you run into when you're developing AI. And every single one of these features is a massive quality of life win for a developer. Fresh start safe? That just means if your training gets interrupted, you can pick it right back up, no sweat. Things like automatic mixed precision and FP8 support are all about maximizing your speed. And my favorites, out-of-memory backoff and progressive growth, are there to prevent that dreaded GPU crash. It's a seriously professional setup, right out of the box. Okay, beyond the cool toolkit, the real magic here is in the model's architecture itself. This is where the script gets super clever, saving a ton of memory and compute power by using something called low-rank multi-head attention. The core idea here is low-rank approximation. The best way to think about it is like this. Instead of copying an entire massive textbook word for word, you create a really good summary. Yeah, you might lose a tiny, insignificant bit of the original detail, but your summary is way smaller and so much faster to read. That's exactly what this model is doing with its math. And this right here shows you the payoff. Traditional attention has to calculate the relationship between every single word and every other word in a sentence. It's a lot. It's slow and it eats up memory like crazy. The low-rank method finds a clever mathematical shortcut to get pretty much the same result, but with just a fraction of the resources. It's a total game changer. So where does this all happen in the code? It's right here. In the low-rank MHA class, this one little line creates a compressed matrix. That's our summary we were just talking about. This is the piece of the puzzle that makes that whole efficient shortcut possible. It's such a small snippet of code, but the impact it has on performance is just massive. Okay, so having an efficient model is one thing, but actually training it, that's a whole other beast. It's basically a gauntlet of things that can go wrong, from running out of memory to just taking forever. But this script is smart. It actually anticipates these problems and has solutions built right in. This has to be the most common problem for anyone doing this stuff. You've got your model, you've got your data, you hit go, and boom, crash. Your GPU is out of memory. So what do you do then? Well, this script has two fantastic safety nets. The first is out-of-memory backoff. If you run out of memory, it doesn't just give up and crash. No, it automatically makes the batch size a little smaller and just tries again. The second is progressive growth, which is a proactive way to start small and then get more ambitious as the training goes on. And you can see that plan in action right here, just using the default settings. You just turn it on with a simple flag, and every 50,000 steps, it tries to level up to the next block size. It's a totally automated way to push your hardware right to its limits, but safely. Okay, so the next hurdle in our training gauntlet is just pure speed. Waiting around for days or weeks for a model to train, it's not just boring, it completely kills the creative flow. So how do we speed things up? One of the key ways is by changing the numerical precision. As you can see, there's always a trade-off. Standard 32-bit numbers are super precise, but they're slow. This script lets you use 8-bit floats, or FP8. You get perfectly good precision, but with a huge boost in speed and a massive drop in memory usage. All you have to do is add a simple flag. All right, so after all that super efficient training, we finally get to the really fun part, making the model actually generate some text. This is where we turn all that stored up knowledge into something new and creative. Now, big picture, there are two ways to go about this. Greedy decoding is the most straightforward. At every step, it just picks the single, most likely next word. It's safe, but it can get really repetitive. Sampling, on the other hand, adds a bit of controlled randomness. It picks from a list of likely words. This is where you start to get more creative, more diverse results.
And the script gives you this whole dashboard of what I call creativity knobs to control that sampling. You can dial up the temperature to make the output more random, use top K or top P to narrow down the pool of choices, and even hit it with a penalty to stop it from just repeating the same phrases over and over. This chart shows exactly how top K works. So let's say you set K to 3. The model figures out the probabilities for all the possible next words, but it just throws everything away, except for the top 3 most likely options. The final word is then randomly picked from just those 3. It's a great way to filter out a lot of potential nonsense. So we've seen the toolkit, the architecture, the training tricks, the generation, but let's zoom out for a second. Why does a script like this actually matter? What's the bigger picture here?
What's really, truly important here is that this kind of thing democratizes AI development. When you have powerful, efficient, open-source tools like this, you dramatically lower the barrier to entry. It means students in their dorms, independent researchers, startups on a tight budget, they can all experiment and build on the cutting edge. It's not just a game for massive tech labs anymore. And this right here is a perfect example of what I mean. A huge research paper discovered there's an optimal ratio for training. For every internal knob the model can tune, that's a parameter, it should see about 25 words of data. That's the sweet spot. Any less, and the model just memorizes. Any more, and it's not learning efficiently. Well, this script automates that whole insight. It actually counts its own parameters and sets the right training target for you. It bakes best practices right in. All of this really leaves us with one final exciting question. When tools this powerful are made this efficient and this easy to use, it just opens up a whole world of possibilities. It's not about what a few giant companies can build anymore, but what all of us can create. So, what are we going to build next?